All right, dear friends, let's rock this. Physics Lesson 7, Kinetic Energy. Please open your physics booklet to page 55. Okay, so kinetic energy is the actual energy of motion. So EK occurs when you release the stored potential energy within an object. Here's one more equation for us to put in our little tool belt. Now, EK equals half of mv squared. So we've seen mass before, we've seen velocity before, and now we have EK right here. Copy this down in your book, please, on page 55. Okay. So since it's a form of energy, it gets the same units as potential. We're talking EK equals kinetic energy, which equals units of kgm times m over s squared, or nm, or J for joules. Please put this down in your book on page 55. Okay, let's get to work. So, how much energy would a soccer ball have if it is kicked at 10 meters per second with the note that the mass of the ball is 0.70 kgs? So, as usual, we'll start with our old friend grasp. And out of grasp, we will figure out that this thing has a velocity of 10 meters per second and a mass of 0.70 kgs. What's required? Well, we're looking for how much energy this ball would have. So we're looking for EK. So that's our big question mark. Now let's put down our fancy new equation for this analysis. EK equals half of mv squared. Okay. Well, it looks to me like if we want to solve it, we can just plug away. So boom, we're just going to throw our numbers right in there. 0.70 kilograms times 10 meters per second squared equals 35 joules. And bingo, right there. We already have our sig digs, so now all we need to do is paraphrase. The 0.70 kg soccer ball will have 35 joules of kinetic energy if it's kicked at a speed of 10 meters per second. Take a minute to just copy this down in your notes. Okay, pause if you need to, otherwise we're moving ahead because it's your turn to get to work. Now this one's a little next level. My big hint for you as you work on it is that you're going to have to use previous equations. This brings together a lot of our previous knowledge, a lot of our previous equations. So a small rocket is launched into the stratosphere with a force of 5.0 newtons and accelerates from rest at 2.15 meters per second squared for 3.2 seconds. How much kinetic energy does the rocket contain after 3.2 seconds? So as usual, start with grasp. What is this? What is the given? Now pause your computer, take a few minutes and give it a shot. Okay, you did it. Here we go. Let's take a look at it together. So we're going to start with grasp. Now, first off, we've got given. So what is given? We have the force of 5 newtons. We have the area of 2.15 meters per second squared. And we have the difference in time being 3.2 seconds. Okay, fair enough. That seems straightforward enough. So let's take a look here. What is required of us? Now, let's see. They're asking for EK. How much kinetic energy does the rocket contain after 3.2 seconds? Okay, well, let's take a look at our new fancy equation and see if we can just plug the numbers in. MV. Now, usually, the question kind of gives us 2 out of 3 of the variables there, 2 out of 3 of the little symbols, and this doesn't give us any. So, what could we possibly need to do? Well, we'll have to bring in our old friends, some of our older equations. Now, what equation uses that F? I remember. It's F equals ma. Okay. I feel like we can figure this out. Okay, so if F equals ma, we have F, we have A, and we need an M. And hey, we need an M in our equation. So let's just work this out. Let's just plug it in and make it happen. So we're looking for the M here. So we'll just switch that around. M equals F over A. And we'll just plug those numbers that we just got into there. Boom, 5 newtons, 5.0 newtons over 2.15 meters per second. And that will give us 2.33 kilograms. Boom, just like that. Holy moly. This is like pretty amazing. Now, the units seem kind of wonky, but if you recall our expanded form of newtons, that's what it gives us. So, here we go. Let's keep going. So we have the M. We must need the A now, the V now, because, well, that's what our equation calls for. So what do we know that uses these units that we have available for us, these numbers that we have available, to give us a velocity? I know. It's the acceleration one. And you know what? We have acceleration and we have time. So we can swap this little guy around too. We can say delta V equals A times delta T. And that'll give us what we need. Okay, so let's just plug those numbers in. So we'll do 2.15 meters per second squared times 3.2 seconds. And boom, we have 6.88 meters per second is our velocity. Okay, so let's see, we have V, we have M. Now we can totally just plug in our final equation. Let's do it right here. So we have EK equals half of mv squared. Okay, let's plug it up. So we're going to say half of 2.33 kgs times 6.88 meters per second squared. So let's do that math. And that'll give us 5.504 kgs times meters squared over s squared. And wait a minute, what does that mean again? That's right, that's joules. That's what that is. Perfect. Okay, and we know that we need to have, how many is our weakest number in there? 3.2 has 2 significant digits, so does 5.0. So our answer must have 2 significant digits, which will round to 55. So our kinetic energy is 55 joules. So let's wrap it up by paraphrasing here. If a rocket is launched with a force of 5.0 newtons and accelerates for 2.15 meters per second squared for 3.2 seconds, it will contain 55 joules of energy. Wow. What a mouthful. That was next level. Take a moment, pause for as long as you need to copy this down. If it didn't quite go with what answers you came up with, try and figure out why. Take a look at it again. See if you can make a little bit of sense of it. Take a minute now to do that. Take a breath. You can do this. This is next level. Remember that. This is that example that I give at the end that brings it all together. So this is like super next level. And again, welcome to being a full-fledged scientist, my friends. If you have any idea what's going on here, you must be super smart. Okay. Pause now if you need to, otherwise we're moving on. We did it! Okay, please complete the practice assignment on page 56. If you are feeling overwhelmed right now, or just like, wow, that was too much all in one little thing, you're in luck because these practice questions are made in a way that starts and it builds and it builds and it builds, and it'll get you to where you need to be. So I would like you to just work through those questions right now. Just give it some effort. Just see what happens. Thank you very much. Good luck.